Hello, everyone. I get you want to see the conversation, so I'll keep this short and sweet. I just want to apologize because my laptop died halfway through filming. So there's going to be this kind of awkward transition around 20 minutes. I also want to apologize because my microphone's a little bit more muffled than Dr. Gayley's is. Not a huge deal. He talks far more than I do. He's the star of the show. But it's just due to wires and my setup being a little bit more humble than I care to admit. This all being said, I think it's something you guys are all going to enjoy, and thank you for watching. Well, hello everyone. I thank you for tuning in and watching Never Stop Questioning. I'm Cole Dorman, and today's guest is Dr. Ken Gayley.
I better make sure I'm actually on the picture because I know I'm a little bit on the edge of the screen, so I'll try to make sure you can see me.
It's no worries. But if you want to introduce yourself, maybe what you do here.
Okay, sure. I'm Ken Gayley. I've been here at Iowa since 1997, so I guess that's about 23 years now. And what I do is I'm a faculty member in the Physics and Astronomy department. And I come more from the physics background myself, but I'm more officially in the astronomy side of things. So I really cross over, and there's not much of a line anyway between physics and astronomy because physics is the rules of nature, and astronomy is those rules playing out on the massive and most largest and amazing scale possible. So I've always thought of astronomy as just the application of all the physics that I've learned. And so I was happy to come here and start teaching students astronomy and also do astronomy research myself.
Yeah, and so you said you came more from like physics. Did you know that you wanted to do astronomy, or did it kind of just play out that way?
No, it's a good question. It just played out that way. What I knew is that I wanted to do physics. I've always loved physics. I've loved the idea that there are these so-called laws of nature. There's simple rules that are not always so simple, but they are remarkably simple compared to what they could have been. And I've just thought that was really neat that that's true. And so I wanted to learn what those rules were and see them playing out around me. But in the course of my process, I found opportunities that were more in the astronomy realm.
Yeah.
And so I was guided over into astronomy by an unusual path because, you know, there's a lot of students that do take astronomy, and they're very often students that own telescopes themselves, and they get out in the backyard and they're very curious about the sky. And so astronomy is a natural fit for them. But I was more around the laws of physics that are happening in the daytime and not necessarily going outside at night looking at the stars. But when I was a graduate student, I had an opportunity to do a research project on solar flares. And it was basically a physics problem is what makes these electrical discharges occur near the surface of the sun, which can blast a lot of plasma out into the space between the sun and the earth, and can even come to the earth and cause aurora borealises and maybe even knock out some power grids from time to time, possibly even knock out some satellites. So the solar flares have an impact on the earth, but my interest was in the physics of what's causing them. And so I started working on that project as a graduate student. And then after I graduated, I got a PhD doing that. And then the usual thing you do after a PhD is you do what's called a postdoc, or a postdoctoral research appointment, which is a short-term 2 to 3 year project typically. And you're just trying to show that you can do independent research before you get hired in a more faculty-type job. And that turned out to be in the flares on stars other than the sun, but that are kind of like the sun.
Yeah.
Ironically, these stars are called cool stars. The sun is considered a cool star. It doesn't seem all that cool on a hot August day in Iowa.
Relative.
That's right, all relative to the really, really, really hot stars. But anyway, a lot of these stars have solar flares or flares like the sun. So that's what I did my first postdoc on. And then I got a second postdoc because sometimes that's what you do in this business. You don't get a faculty job right away. In fact, it's not that unusual that you don't get a faculty job at all. But I was fortunate that after the second postdoc, I did get a faculty job. But the second postdoc was on hot stars. So I did my first postdoc, I did my PhD on the sun. I did my first postdoc on cool stars, and my second postdoc on hot stars.
You got it all covered.
I got it all covered. I got all the stars covered. And at this point, I just had to, at some point, accept that I'm an astronomer. And it happened kind of gradually like that because it's still the physics I'm doing. I'm still teaching physics classes or taking physics classes. And, but then when I was hired at Iowa, it was like they were looking for an astronomer, and I had to realize that, yeah, that's me. I'm an astronomer. I learned all about stars. What are stars? They're astro objects. So I am now an astronomer. And it was a gradual process.
I feel like more people today are more drawn in from astronomy than physics. At least people I know.
Yeah, that's true. That's true. In fact, on the personal side, where that happened was, originally I would tell people I was a physicist. What do you do? I'm a physicist. And I would just see their faces just kind of go like, oh my gosh, I took physics, I hated it all. I'm not going to have anything to say to this guy. And so I've taken to not saying that I'm a physicist. I say that I'm an astronomer. But it's really more true anyway. And it's the opposite effect. If you say an astronomer, their face lights up. Oh, astronomy, that's so cool. What about this thing in the sky? And what about this other thing? So it's just a way better conversation starter to say you're doing astronomy than physics.
I feel like you can also, like, if you really want to impress them, you can say, like, astrophysicist.
So astrophysics is a very loaded mouthful, but then they think you're Stephen Hawking or something like that, right? So they figure, oh my gosh, again, you'll be in this boat where it's really cool stuff, but I'm never going to understand anything you say. But that would be a shame, because really the whole point of astronomy and even physics is to make it understandable, because we have these things going on around us all the time that it seems so inscrutable, but physics figures out what's really happening in a way that should be accessible to everyone, at least at some level. And that's even more true of astronomy. So we want to make astronomy accessible so that anyone can understand why the sky is blue, why the sunsets are red, why the planets go around the way they do. This is something that we all have the ability to understand. So as an astronomy educator, I try to communicate that message, that this is accessible to everyone.
What would be your argument, I guess, to teach astronomy over physics? Or you're not saying that,
Yeah, I understand. Well, I get that opportunity because I do teach both astronomy and physics. So I'm constantly, like this summer I'm teaching a physics class, and I constantly want to use astronomy examples to explain the physics. And I have to sort of back away from that. I have to say, well, wait a minute now, I'm teaching a physics class here, not an astronomy class, so I don't want the students to feel like, how did I end up in an astronomy class? But astronomy does provide lots of great examples of these physical principles.
It's still like large scale too, you can see all of I feel like when you have examples like here on Earth, a lot of like the small parts of it really can be hard to imagine. With astronomy, every moving part is so large that it can be quite easy to visualize.
That's right, and that's particularly true in terms of this area of physics called quantum mechanics, which is the most difficult physics probably. And it's happening on scales inside atoms, so they're so impossible for us to get our head around. If you think it's hard to imagine the size of the universe as this incredibly large thing, it's even harder, I would think, to get your head around what it means to be inside an atom. And the rules of the game are so different in there.
Oh my gosh, I know.
And we talk about atoms. Astronomy is filled with atoms, and we have to do that physics, the physics of atoms. But by and large, it's like what you're saying, that astronomy is big, and the rules of astronomy are planets going around stars and stars going around galaxies. It's gravity. It's like Newton's law of gravity, which was discovered 400 years ago, and we still use it as our main tool in astronomy. So that does make astronomy a little bit more within arm's reach, I think.
This is kind of just an astronomy question, because I'm curious. Do you get to kind of so quantum mechanics is just so much probability. Do you get to kind of step out of probability when you're doing astronomy because it's so large scale? Or is the probability of it
well, that's a good question. There are, what he's talking about is when you get down into the scale of an atom, you can't tell where a given electron is going to be at any given time. It has a very unclear and uncertain future. But you can figure out probabilities, and that's and remarkably, quantum mechanics is extremely accurate at these probabilities. You can calculate what the probabilities are to a very high accuracy, by which I mean if you were to do the experiment 1,000 times, you would know pretty much exactly how many times each outcome would occur. But you wouldn't know which outcomes would be which, so it would feel like rolling dice. Whereas in astronomy, it's like the motions of the planets, the motions of the stars, it's like clockwork. It's all very well and easily predicted to a point, but there is still a lot of details that, I mean, astronomy it's a big place. And so the main things that are happening are simple. The sun's gravity is ruling the motion of the Earth. The Earth's gravity is ruling the motion of the moon. But there's other things. There's Jupiter's out there. It's pulling on things. There's other planets. There's every once in a while we discover some new system, some new object that is orbiting the sun. And it's pulling on things just a little tiny bit. So you really can't include everything. And so there's a tiny bit of uncertainty. And where this shows up is in things like, if you want to predict the return of Comet Halley, which we always do, it's one of our impressive wins in astronomy that we can predict when Comet Halley is coming back. But we can't predict like the month it's coming back because there's things happening to the comet that are slightly unpredictable.
Yeah.
And there's also, if you want to talk about an asteroid that's going to hit the Earth or something like that, we always hear about this in the news. Oh, there's some asteroid that's coming within the orbit of the moon. You know, is it going to hit the Earth? Well, fortunately, the orbit of the moon is very, very far out. So even if it's coming within the orbit of the moon, it's still going to miss the Earth.
Yeah.
But there is a chance. There's a tiny chance that it would hit the Earth. And we can't tell. We have to watch the asteroid come and try to figure out. We really can't predict to that level. So there is still some probability involved even in astronomy.
Yeah, definitely. So I know earlier you were talking about, you know, your path to becoming an astronomer. I guess kind of want to dial that back a little bit. What got you started, so what got you started in physics?
Well, in my case, it was a pretty simple story because my dad was a physicist. That's how it goes. And it wasn't so much a desire to kind of like be like my dad. Mm-hmm. It was more I had curiosity and I could ask him questions. Mm-hmm. And unlike Calvin's dad in Calvin and Hobbes, who just like makes up funny answers that are ridiculous, my dad could give a pretty good sounding answer to these things. And I thought that was really cool that you could say, why does this happen? And there's a reason. It's not just never mind, it just does, go away. Mm-hmm. It's, oh, that happens because of this, that. And then it's a question of how deeply do you want to go into it? Do you just want a superficial answer that will satisfy you, or do you want to dig into this and really see what's happening? And you can do that with physics. So I thought that was really cool. Mm-hmm. And then when I started taking physics in school, I discovered that I had the attributes that allowed me to do the mathematics of it. So it takes a certain kind of person that thinks a certain way to be able to do physics. Mm-hmm. And you don't really know for sure if that's your way of thinking until you try it. But for some people it is, and they can be successful at physics. So it worked for me, and so I liked it, and it seemed to like me. So it was a marriage made in heaven in that sense, and it's been good to me ever since.
So did like your undergrad and graduate schooling go relatively smoothly then, or?
They did. I mean, there were challenges, of course, and it is challenging to learn physics. And there are times you really have to get used to the sensation of not understanding. If you want to learn physics, you know what that feels like after a while. Like, oh yes, this is that feeling I get when I totally do not understand. And the key is to not be discouraged by that feeling because it's a step in the process. Mm-hmm. It's not the final state, thank goodness. The final state is more like a light bulb coming on. And so you start with that painful feeling of, I don't get it. Why are they talking about this? Or what's happening? Mm-hmm. And then, oh, wait a minute, this is starting to make sense to me. And the great thing about physics is that process of it starting to make sense and the light bulb coming on, it never stops. It keeps on going. You not only because you're learning new things, you're learning the same things again in a way that suddenly makes a lot more sense than it did before. Yeah. And so I feel like I don't really understand anything until I've taught it, and more than once. And I'll have the experience of I'll be in front of a classroom and I'll be explaining something, and I'll pause for a second and I'll just think, oh, that's really cool. Yeah. You know, I never realized that before. So that's the cool thing about physics.
I totally understand that feeling of like, you really learn it once you have to teach it. Because I remember earlier in the summer, whenever I did outreach stuff, kind of doing the presentations out to the public, you know, I learned it all in like general astronomy. But then I had to go back and I had to think like what potential questions like people in the audience would have. And then that's what really forced me to like kind of learn it, because I don't want to look silly if someone asked a question. I just had like,
that's right.
no clue what was going on.
And they will too, and they will. And sometimes they do ask a question where you just have to pause and think, you know, that's a really good question. Yes. I've never even thought to ask myself that question, so I don't know the answer. and or fortunately I did think to ask myself that question, so I do have an answer. But either way, it really is a good experience to teach something. And in fact, I would recommend to students, if anyone's going to listen to this because you're a student and are curious about what may be ahead on your path, do take the opportunity to explain to your classmates and maybe even your family members that your parents might say, so what are you learning? Well, give it a go to try to explain it to them. Or if you have a classmate or a roommate or something, because that's when you start to make sense of it. And if you don't have those, then explain it to yourself.
Yeah.
Because it's really a process of owning this knowledge. You own the concepts, and you make them yours, and that's a really important part.
I think that's one of the most fun parts. I think of I'm not going to say of the job because I'm a third-year student, but it's just being able to really kind of wrap your head around these concepts. I think that are outlandish to so many people, but at this point, you really know them through and through.
Right.
And it's a lot of fun to just get brownie points with people. But I'm sure you're probably pretty used to it at this point. But
to a degree, yes, because there are some things like I mentioned, quantum mechanics is so bizarre. It's terrific. I could talk for an hour on just how crazy and bizarre and fascinating quantum mechanics is, and general relativity, the way gravity works on large scales. It's so amazing, our process of learning these things, where we thought we had it all figured out, and then 20 years after that, we suddenly realized we didn't understand anything. And it's remarkable that physics does that. And so you do kind of feel like, I'm in a privileged class of people because I have the ability and the opportunity to understand to some degree these things. But then the flip side of that is that it's the universe we're talking about, and the mysterious hand that is making things the way they are has plenty of surprises in store, even for the people who think they do understand. And so the more you encounter these new ideas, and the more you think about them, the more you realize that, there's a whole lot going on here that is beneath the surface still, that I don't understand, and that makes me feel more like physicists from hundreds of years ago, who we now look over their shoulder and say, aha, you didn't understand that, but I do. Yeah. But I know that 100 years from now, there's going to be somebody looking over my shoulder doing the exact same thing. So.
I've really come to terms that I feel like no matter how high up I get, I'm never gonna. The more I learn, the less I'm gonna understand. Yeah. It's
like a frontier where it's always bigger. The outside of the bubble is always bigger than the inside. So you have to kind of enjoy that sense that there's more out there, and not be discouraged by that to really enjoy physics.
Yeah, absolutely. And I think it's always, important whenever I tell people, they're like, how'd you do it? At the end of the day, I started from physics 101, and so everyone, and so while you're never really going to understand everything, there is a lot that there is to be learned.
Yeah.
And so I can appreciate, kind of going back earlier, that everyone should learn physics, just outside of the fact of not only just it's good to know, what's kind of like how the world around you interacts, but also just become more comfortable with not understanding things.
Yeah, I think there is a lot to be said for physics as a general education experience. So not for people they're not going to be professionals in physics, but they just want a taste of it, to get a sense of what it's all about. It's a great way to get the scientific method, and astronomy I think is particularly good at this, because the history of astronomy is really the history of inventing the scientific method. And the way these discoveries were made throughout history is a terrific way to learn the way science works. And so I do feel like everyone should have that experience, just so they understand what science is. And then the beauty of it is you can apply it in your own life, because you can go outside and look up at the moon and look at its phases and go, yeah, I always thought the phases of the moon are kind of mysterious, but now it's like I totally understand it. I see exactly why it's doing that. Or the seasons, you can understand why, instead of just saying, well, yeah, somebody told me once it had to do with the tilt of the earth, but I don't really get it. Instead, you could be, oh yeah, I totally see the days are going to be longer because of this, and the sun is coming down at a different angle, so yeah, it's going to be warmer. And so these things that are affecting us on a daily basis, they don't just have to be things that we take for granted. They can be things that we actually understand to some degree, anyway.
So I know a little bit earlier we were talking about how your journey from becoming a physicist more into astronomer.
Mm-hmm.
Was there anything else that really from the outside world, well, the outside world, quote unquote, that kind of shaped you into the scientist you are today?
Well, I think in my own case, I probably had a pretty standard kind of experience. I really didn't have any earth-shattering events that kind of did that. It was, I jumped on the bus, and there really is a bus that is the educational process in physics, and I'm sure it's the same in other sciences as well. And they take you through the steps, like you were talking about Physics 101. So you start with this. You don't even know that there's quantum mechanics down the road. You don't even know that there's all these other ways to think about even Newton's laws.
I know my classes 3 semesters from now. So
oh yeah, it's almost like they intentionally hide this from you because you're not ready for it yet. So we're going to teach you a bunch of stuff, and then later on we're going to expose what's underneath that. Mm-hmm. And you're going to find out that these things we call Newton's laws, which were one way of framing why everything's happening the way they are, can be reframed in a totally equivalent but very different sounding way, more mathematically sophisticated, but more importantly, just a philosophically completely different way to think about what's happening. And that's what you're exposed to a few years later. And then after that, you get more in quantum mechanics and relativity. And so little by little, you become more prepared and ready to take in these more sophisticated notions, and that's when you get them. So the bus takes you to these stops along the way, and if you stay on the bus all the way, you get to the PhD, and then you do the postdocs like I did, and you're ready. You've been trained to do this particular thing. So I was fortunate enough that I did actually get a faculty job, and there's no guarantee that will happen. So if you want to be on that bus, it's important to keep your eyes open and look out the window and see opportunities, because like when I teach my students, I only know what I did. I know.
Yeah, it was kind of abrupt, but we're back, and
technical difficulty.
Yeah, technical difficulty. But I just know we were talking about like learning experiences. I guess we were talking more about the bus that is.
Right, that's right. And I was saying that it's important to see the landscape and look out the window, see the landscape, because we can take you through the stops, but we can't guarantee what's at the end of the rainbow there for you. So it might be a faculty job, which I think is a great job, because I love being a faculty member. I get to teach, which is fun because it's a room full of people that pretty much have to listen to you. You're going to give them a grade, and you do have some interesting things to say. And so you're given that opportunity to be the one who gets to share this knowledge. And so that's really fun. And then you also get to learn some things yourself by doing research. You learn about stars, learn about the universe. So it's a nice balance, and I like the job a lot. But there's many other ways to use these skills. These are skills in quantitative reasoning and looking for how to simplify. That's really what a physicist does. They take a complicated situation and they simplify it by looking for unifying principles. And these are powerful in many real-life applications. And many of those real-life applications are unknown to me and other physicists. We only know our own area. So if you have your eyes open, you can find places to apply this approach to thinking and sort of carve your own niche. So that's a valuable thing to bear in mind as well. But in principle, you can go into academia like I did. And academia is all about this balance between sharing the knowledge that we've already acquired and adding more to it.
What made you choose academia over industry, or did you always just kind of know?
I've always been on that road because, and again, part of it I'm sure was that my dad was an academic, so I could see that it was a good life. It was one that I could picture myself doing, and I knew that I would enjoy that job. So I was always on that road myself, and nothing really tempted me. I might have had opportunities to make more money doing something else, but the money I make is fine. I'm perfectly happy with it. I don't know what I would do if I had, more expensive toys or something. It wouldn't be worth it. It wouldn't be worth trading away the ability to just wake up in the morning and say, okay, what am I going to learn about the universe today? That would be a high price to pay to have to part with that. So I was always happy to be an academic.
Does it ever get like stressful, just the publish or perish
It is,
type
yeah,
lifestyle?
but I don't think it's any worse than any other kind of profession.
Yeah.
Because anytime you're in a profession, you're always a little bit concerned that it might not last, that
Mhm.
you might lose your job, you might be outcompeted by someone else if you're in the business sector. So there's always a degree of pressure, but it doesn't get any worse than kind of what you need to motivate you. It's okay to have a little bit of pressure to motivate you.
Yeah.
So I was okay with it.
So we've been talking really about like this bus the whole time,
Yeah.
and so getting to the end of the journey, at least education-wise, the bus. Do you have any just advice or tips for people who are just starting out, and through all, I guess, sectors of education?
Yeah, I think my main advice would be, first of all, what we already said, is don't be discouraged by that sense of not understanding. It doesn't mean that you're the only one who doesn't understand and everybody else does. No, it's part of the process to not understand. And it guides you to where you need to apply your energy. You need to apply your energy to the things you don't understand, instead of shying away from them, which is like that expression I get I see on people's faces when I say I do physics. I see the expression that says, that's something I don't understand, and therefore I'm going to shy away from it.
Mhm.
Instead, you have to go right at it. Find the thing you don't understand and come straight at it in order to gain that understanding and make the light bulb come on.
Mhm.
And sometimes that will mean reading the book a second, third time.
Yeah.
Often it will mean trying problems. Problem solving is the way we train ourselves to think in
Mhm.
physics. And another thing is to talk to other people.
Yeah.
Talk to your classmates, and what they may have figured something out that you haven't yet, and maybe you figured something out that they haven't. And so it's a win-win to share information with other people. So that's what I would say if you're in this process, is to try to be as social about it as possible, make connections, make friends that have similar interests,
Mhm.
and talk physics. And then try the problems until you understand. Don't be satisfied with a question that goes unanswered.
Yeah.
Try to formulate questions and try to get them answered.
Definitely, I think that just the biggest. I guess I should say I don't think people should ever shy away from asking for help.
Mhm.
There's no shame.
Right.
And needing help on a problem or collaborating too. I think just physics in the real world is so collaborative as well. That's always smart to
is.
kind of learn to play with a team.
Yes, that's right. That's one of the things that distinguishes academia from the business sector. In the business sector, if you figured out something that's going to make you a lot of money, you clam up in a big way.
Mm-hmm.
In academia, if you figure out something that everybody should know, you yell it from the mountaintops.
I guess kind
So-
of polar opposites.
Yeah,
in a
they
sense.
really are. Mm-hmm.
But so I know I wanted to ask you a little bit about a play that you wrote.
Mm-hmm.
What was the whole process of that like? And I guess just tell me about it.
Yeah, that was a fun process. I first have to begin by saying I had a close association with a professional playwright in
Okay.
Iowa City, whose name is Janet Schlapkall, and she was my guide throughout the entire process. So
Mhm.
there is no possible way that I could have come up with anything close to this play without her help. And I don't just mean tips of advice. She read the script, she made suggestions, she was huge throughout the entire process. And she was the reason I wrote it in the first place, because she leads a group that puts on plays, and so they wanted a play to put on, and she asked me if I could maybe write a play, and she would always say to, and continues to say, write what you know, write the things that you know. So I wrote a play about a physics professor, and it's not autobiographical. This physics professor has a lot of interesting and weird and somewhat controversial events in his life and attitudes that are not my own. But nevertheless, I framed it as someone who does cosmology, which is the history of the entire universe as a whole. And he had a kind of he had a drive to come up with a theory that no one else had thought of before. And the pressure to do that made him go a little bit outside the bounds of what professional academia is supposed to do.
Yeah.
And so he got himself into quite a bit of trouble. And the play is about his student. He has a student who has a more appropriate way of doing things, and so there's a certain tension between the professor and the student there. and that's the way the play plays out. But it was fun to write. It's really about the process of learning about the universe, and sometimes you have to go a direction that no one else has gone before.
How long did it take the whole?
It took maybe three or 4 months to write the play, and I know Billy Crystal said something once that was interesting. He's not known as a writer, but he did write a book, and he said that writing is rewriting. And now I understand what he means by that, because I thought I was going to write this play in 1 month, and it actually took 4 months, because writing is rewriting, and so I had to rewrite most of the play before it really was good enough, and so that was a fun process to come up with something that I could be proud of at the end, and that was that.
Were you always like interested in plays and playwriting, or was it? I guess I'll let you.
Yeah, well, my mom is an actor. So my dad, the physicist, and my mom, the actor, and so it was a natural fit to write a play about a physicist. So that was probably the main motivation.
Were you always? Is that kind of like a bucket list thing, or was it more of like an opportunity presented itself? It's why not?
More of an option that presented. I never dreamed in a million years that I would ever write a play. But when Janet gave me the idea and said, "Why don't you go for it?" I said, "Yeah, that would be a perfect fit. I can give that a whirl," and I'm glad she did.
I know that being a professor is pretty time consuming. It really it demands a lot out of you. Was it kind of tough balancing both of those things, or?
To some degree, but my department was very supportive. I have this thing that's called tenure, which is yeah, that's right. So in this process, there is the state where you have tenure, which is very good job security, and the purpose of tenure is to do this sort of thing, to allow the faculty to have the freedom to be released a little bit from that constant pressure to publish or perish.
Yeah. And
so I knew that this play wouldn't be a publication that would increase my status as an astronomer, but I did think that it had value. That the play has value to the society. It asks an interesting question that relates to astronomy, and I think it has as much value as a paper that I could have written in the Astrophysical Journal.
There's a saying, I think it's time spent enjoyed is time well spent. So.
Yeah. Well, in fact, I heard once a person said something similar. He was asked by a young person who wanted some inspiration, and the young person said, "What should I do to help the world?" And this famous person, whose name I can't recall unfortunately, said, "Do what you're passionate about, because what the world needs above all is passion." And obviously the young person was a little surprised that he wasn't told something more specific that he should do. But at the end of the day, it does have to come from you. It's your passion, you have to find it.
Well, thank you very much. So I guess I want to ask, where do you find fun in physics, or what's the enjoyment out of you?
The enjoyment for me in physics comes largely from other physicists who have figured something out with such crystal clarity that they want to explain it to other physicists.
Yeah.
And there's a couple of people that are extremely good at this. One of them is a guy named Richard Feynman, who is no longer with us, but Richard Feynman had an incredibly profound understanding of physics, and he was more than willing to share that insight with others. And so he wrote a number of great books that explain physics. And so reading books like that and just marveling at that level of understanding. And others too. There's a long list of people, and they all are well known, of people that write physics books for the general population. And so they're framing physics in a way that can be understood. And these people are so good that I can read it and get as much out of it as the so-called target audience, which is someone who doesn't have a physics background, but I can get just as much out of it because it's so insightful that in some ways I think I even get more out of it.
So do you enjoy, I guess, more the notoriety or more of the ability to be able to communicate the ideas?
I think it's more the ability to communicate, because I feel like we're in this world and it's mysterious and there's a lot going on, but we have some power to figure it out. And if we each share what we've been able to figure out with each other, then we can build up a really significant body of knowledge and understanding of our world.
Mm-hmm.
And so for me, that's the thrill of being able to participate and contribute to that process is really remarkable.
Mm-hmm. I guess that really kind of ties in to earlier what you're talking about, just
Mm-hmm.
wanting to go into academia and be able to kind of share
Yep. That's right.
everything and be able to talk.
Yep.
So I want to ask, what are you excited about in physics today that's going on?
Well, I'm very excited about discoveries moving forward in technology,
Mm-hmm.
like energy. We obviously are at a place where our old ways of getting energy are not working so well anymore because
Yeah.
they're contributing too much carbon dioxide.
Mm-hmm.
And we're going to run out of them eventually anyway. So we need to come up with new ways of getting energy. And so that's going to require understanding the rules of the game extremely
Mm-hmm.
well. And the laws of physics are going to be our aid for figuring out new ways to get energy. And so I like the whole way that technology improvement occurs.
Mm-hmm.
We have the internet now, and everybody's carrying computers around in their pocket that are more powerful than entire roomfuls of computers
Mm-hmm.
50, 60 years ago.
Yeah.
And so the technology is being spurred on. And there's fascinating things in the areas of quantum computing, which again gets down to this weird rules of the game inside atoms.
Yeah.
And if we can take advantage of those rules in a computer, then we can come up with very clever ways to make better computers and improve our technology that way. So there's going to be a number of technological advances, I would think, in
Mm-hmm.
the next 50 years or so. I won't be around for all of them,
Yeah.
but I am excited about the direction that it's going.
Wow.
And in astronomy, I'm excited about the breakthroughs that we've had recently in understanding the history of the universe as a whole, what the early times in the universe were like.
Mm-hmm.
And of course, there's two gigantic mysteries in astronomy right now, which are called dark matter and dark energy. So I won't have time to go into them, but you could Google either of those terms,
Yeah.
and you will discover that what we thought we knew about the universe just even 50 years ago, we thought we had this all figured out.
Mm-hmm.
And now we've discovered that, whoa, there's a couple of huge things that we have not figured out.
So we've been talking about like dark matter, dark energy,
Mm-hmm.
clean energy, which is just totally different.
Yes, right, exactly.
Do you just enjoy reading up on these things, or does your work help play into?
My work does not directly contribute to these things, I must
Mhm.
confess. I've come along a little too late in those processes to have any ability to tailor my expertise in those directions.
Mm-hmm.
But I just find them to be a fascinating direction in which physics is going.
Yeah.
And so I think if I were just coming up now, I might look more at those areas as places that I could possibly contribute.
Mm-hmm. So earlier we were talking about just Richard Feynman and other
Mhm.
physicists who can communicate ideas so clearly. Is there a way that you wish the public was able to consume physics that isn't doing so,
Mhm.
or would you be able to, if you had the power to just be like the
Right.
puppet master?
Yes, well, that's a very interesting question, and you know, it relates to something that Richard Feynman himself once said.
Oh my gosh, full
Because-
circle, yeah.
Yeah, I know, we're going full circle here, because Richard Feynman said that you can tell that we're not living in a scientific age,
Yes.
which sounded at the surface like a shocking statement, because what do you mean we're not living in a scientific age? We have the internet, we have computers, we have we have electric cars, we have
Mhm.
cars that are going to be driving themselves pretty soon. It sounds very scientific to me, but his rationale was that we're not seeing it in the culture, we're not seeing it in the art, we're
Yeah.
not seeing it in the poetry, in the drama. And that was part of my reason for writing that play, which was called Zwicky's Air, which is about
Mhm.
Fritz Zwicky was a famous astronomer who had some very outlandish ideas, many of which turned out to be correct.
Yeah.
And so we don't see a lot of that. We don't see in the culture. When we see science, it's more like science fiction. You know,
Mhm.
there's a lot more science fiction in our culture than there is actual science.
That's a very fair point.
And the classic example of this is the Big Bang. The Big Bang is the expansion of the universe over its history.
Mhm.
And so Richard Feynman was saying, look, we have literally just figured this out in the last blink of an eye
Mhm.
in the human lifetime. And so where is the reaction to this? Where is all the people that are blown away by this new discovery, and it's showing up in poetry and art and all these things? He said, we're not seeing it.
Mhm.
So the discoveries of science are still, in some sense, disjoint from the human experience. And so he thought maybe there could be more connection between the two.
Yeah.
And so that, to answer your question, I would say that's what I would try to do if I was a puppet master and could wave a magic wand, is that I would try to have these insightful ideas about how things work more widely understood and appreciated,
Mhm.
so that people could see where we are in the grand scheme in a somewhat different way. Let me give you a quick example then. I know we're
Yeah.
getting low on time, but
No, don't worry about it.
it's typical to talk about the universe and the scale of the universe
Mhm.
as if we are minutely small, just inconsequentially tiny. And I think that is not a great way to go, because first of all, it makes people shy away from thinking about the universe, because who wants to feel inconsequentially tiny?
Yeah.
So we would shun that and back away from it. But actually, it's really the opposite, in my opinion.
Mhm.
We are part of something that is vast, and appreciating the vastness of the universe does not minimize us.
Mhm.
If anything, it makes us much more important, because we're part of this really, really massive undertaking, and we're part and parcel of it. Yes, we're a small part of it, but we are still part of it. And so we don't need to shy away from that understanding. We
Mhm.
can embrace that understanding, and that's what's so different. You know, even 500 years ago, the universe was this tiny little place that was pretty much the surface of the planet. And some people even, it was more like the surface of the planet as far as they could see and no more.
Yeah.
And now we're not part of this miniature, tiny, inconsequential thing. We're part of this incredibly vast, expansive thing with amazing forces like dark matter and dark energy playing out.
Mhm.
So there's a lot going on, and we're part of it. And so, and appreciate what that means for us in the grander scheme of things.
I think, we can really find optimism in just the fact that we started as animals,
Mhm.
like billions of years ago. And now we can, or really our only limit to what we can observe
Right.
is just the amount of light that comes in.
Yes.
And and so I can appreciate too, being the change that you want to see as well,
Mhm.
talking about how we don't live in a scientific age, and you writing your own play to
Mhm.
contribute to that. And
Right, I totally agree with you. I think that's a good way to put it, is we can actually take pride. We can take pride in how far we've come,
Mhm.
and instead of always feeling bad about the fact that, I mean, we do a lot of things on this planet that aren't great for the planet. So
Yeah.
we should, maybe, it's fine to feel bad about that and try to do a better job of stewardship of the planet.
Yeah.
But at the same time, we can also step back and say, we've accomplished some things here, and we can be proud of that.
Mhm. I think what earlier we were talking about the scientific age, that really resonated with me. Just thinking about, we're wearing masks right now,
Mhm.
but how it's now become almost a counterculture to embrace rejecting the science of the mask,
Yeah.
and so what he said still,
Mhm.
we're talking about like all this optimism and stuff, but it almost feels like we're never going to enter a scientific age.
I'm kind of hoping that, although there's so many bad things about the pandemic, obviously, but I'm
Mhm.
hoping that one of the side effects of it will be that people will understand that when you really need to know the truth,
Mhm.
that's when science is most important.
Yeah.
It's okay to have a limited understanding of the truth when it doesn't really affect our daily lives,
Mhm.
but when it's a matter of life and death, then it is important to know the truth.
Mhm.
And it is important to embrace the scientific approach to finding out the truth. Scientists didn't go in with preconceptions about COVID-19. They figured it out. They figured it out by watching it, by studying it,
Mhm.
by doing science. And so it's the utmost futility to ignore what has been learned about this and just pretend that it's something other than what it really is.
Mhm. Well, I hate to end it on such a pessimistic note
Yeah.
like that, but is there anything that you want to plug or that you've been working on that you want our friend David to check out?
Right. Yeah, well, I don't know that I could add any more other than just to say that David has his own, and anyone else who's watching this has their own process, their
Yeah.
own mission here, their own learning journey.
Mhm.
And it's a valuable thing, it's an important thing, And so I just want to encourage you and anyone else listening to embark on that learning journey and see how far you can go with it.
You know, I guess you could say you could never stop questioning.
Perfect.
So,
It's
yeah,
a perfect title.
Thank
exactly.
you.
Yeah.
All right, I'm going to get up and end it now. But thank you so much. I should sit down for this.
Right.
Thank you so much for coming.
Mm-hmm.
I had a really great time being able to chat with you.
Me too.
Thank you, David and Dr. Roberts, for tuning in, and anyone else who's
Thank you
joined.
so much, Cole. Thank you, Ken.
Okay,
This
my
was
pleasure.
wonderful.